Hey, this is Dr. Bragg. I'm doing this second chapter 6 video. So this is chapter 6, video 2. And the third video I'm going to do, it's just the interactive activity. It's just to make sure that you've got everything correct for doing percent composition and turning it into empirical formula. It's not necessary. You don't have to watch that one. It's just to give you more practice, and it's kind of a fun little exercise. It's that one up here about it's got this little thing. It's like a murder mystery, so some people might think it's fun. Trying to lighten the mood a little. All right, so again, like in the last chapter notes, all these links are active links. So if you need to go to OpenStax, there you go. That's linked to the 6.3 in OpenStax. And then if you're, notice there's 2 different Dr. Bean videos to watch. So
you may recall from the first chapter that
this is interesting because it reminds
you may recall from the first chapter that
about the homogeneous mixtures, and it gives you the information you need to start thinking about concentration and molarity. And also, I really like the Tyler DeWitt stuff. This is him working multiple problems. And again, I don't feel like he skips steps hardly ever. And so if you just need to watch someone work lots of problems, it's a great place to go. All right, so just to give you some reference, what is your own experience with different concentrations of mixtures? So I'd probably just like stop and just see what you are thinking about when you think about mixtures and concentration. Some people might be thinking of orange juice. If you buy concentrated orange juice, and then if you add just like 2 cans like it says, or 3 cans or 4 cans, you're going to really get diluted orange juice if you add a whole lot of cans of water into it. There's different versions of salt water. So some bodies of water are more salty than others. And one of my favorite ones to talk about, we'll see today, is sweet tea. We'll talk about sweet tea and how different people make it. I know you're probably thinking there's only one way, right? Everyone has their own way. So have you ever reached the limit of something's ability to dissolve, and how did you know? By the way, the scientific word for that is saturated. I'm going to zoom in and draw a little picture. So if we go to our tea example, so here we go. We got ourselves a cup. We've got us some tea in here. There's our tea. I've got family from Ohio. They love ice in their tea, so I'm going to put a little piece of ice in, right? We got some ice. And then the key thing is that they put sugar in it. I don't want the tea to look crazy. I want you to make sure that you see the sugar going in. Sugar sitting at the bottom. This idea can be used with all different kinds of things. If you think about, like, if you've ever tried to take some of that Gatorade concentrate that comes in like the canister, and you're trying to make it really dilute, maybe you don't like it, I don't know, I end up trying to make it really dilute, and then you're stirring it, and then you end up with, like, at the bottom there's like little pieces at the bottom of like this pile of sugar. Sometimes that happens with cooling too. So when you have that pile at the bottom, that is telling you that you reached the max amount dissolved. Even though you've stirred it to death, the maximum amount dissolved. Now we're going to come back to the Southern sweet tea example in just a minute, which I have been thoroughly educated on. So we want to mention 3 words. There's a word solute, solvent, and solution, and I know these all sound similar. They all start the same way, and you're like, how am I supposed to remember these words? They all even have multiple similar letters. So this is how I remember them. So if you look at solute, and I'm going to use, I'm going to do the green. So we count these letters. 1, 2, 3, 4, 5, 6. This one has 6 letters. Oops. This is the Megan method here. This one, 1, 2, 3, 4, 5, 6, 7. Notice this one has 7 letters. And then I'm sure you can see that this has the most letters over here. So this is my little hint for who's who. The solute is what you have in the least amount. So like in the example I just gave, this would be the sugar. Most of the time you're putting the solute, it goes into the solvent. In this case, you could say that, you could say the tea was the solvent, or you could say that water was the solvent. In general chemistry, most of the time it's water. And then the solution is what you get when you stir and stir and stir and stir and stir. Now, if you still have that solid on the bottom, that's totally fine. The solution is just all the liquid around the solid. We kind of ignore that the solid's there. So the solute, which is the smallest word, is what is in the least amount. You put the solute into the solvent, which in J chemistry, it's going to be water. In industry, this can be all different kinds of solvents. It doesn't have to be water. A lot of solvents in industry have a really strong smell because they're organic things. So if it's got a strong smell, it's not probably water. And then solution, this is the one that has most letters. That's what you get when you mix it all up. Okay, so again, I've got a word bank because I'm trying to keep you actively involved. So if you'll pause it, just try to, I know there are a lot of words on this one, so just give yourself a chance, and you don't have to have it all done, but just think it through and try to do some of them. So go ahead and pause the video. All right, and I already gave you some tips on some of these. Solute is the substance that has the least amount in the mixture. For general chemistry, think of this as the solid being added to a liquid. And you may or may not have caught my little hint with the tea and the sugar being in the water, but there can be many or multiple solutes in a mixture. Like I said, the tea goes in there first and it's just dissolved in, and then we add the sugar in. All kinds of drinks are like this, like any kind of a frozen concentrate that then you add water to it. Lots of opportunities have multiple different solutes in a mixture. I mean, our water, like if you buy bottled water, unless you're buying the super, super fancy stuff, it's got multiple solutes in there. And then a solvent is the substance that is the most amount of the mixture. So water is one of many solvents. So again, it's one of many, but it's very common in general chemistry. A solution describes the amount, or you could say the number, of solutes. And these are what's dissolved. Remember, we're not talking about what's sitting on the bottom. That's not dissolved. It's dissolved, not dissolving. Because the amount of solute in a solvent can vary. The word concentrated is used to describe how much solute is dissolved or combined with a certain amount of solvent. And we use that like in normal speak, not just chemistry. Let me make sure I cross these out. Amount, dissolved. The word concentration. Concentration. Y'all knew what I was saying. Now, if you want to pause now and try to get the rest of them, you can. I'm going to keep going. Concentration describes solutions which are homogeneous mixtures. That just means that if, like, I took some tea from one part and I drank some, and then I drank some tea from, like, a different side of the container, like, it still is the same concentration throughout. It's not like a chocolate chip cookie where sometimes you'll bite into 3 chocolate chips and then another time you might just bite into 1. So concentration can describe mixtures in any phase of matter. So what that means is you can have a gas mixture. We actually are breathing it right now. The gas we breathe isn't pure oxygen. So it can be any phase of matter, and it can be any amount until you reach the limit of saturation. So I'm going to mark out homogeneous, phase, and saturation. Okay, saturation describes the maximum amount of, and you could say solute or whatever, but I was going to say, but what I have that's left is mass that will dissolve in a volume So mass and volume. Did I lose my word mass? Nope, there it is. You know what? I'm going to change that word to amount because I'm going to use volume later, but volume would be appropriate also. Amount. At a certain temperature and pressure. Okay, we're about to talk about that. So an unsaturated solution is more dilute. Oh my goodness, my word bank lost the word temperature. I'm going to have to fix that on your copy. Your copy will have these. Solutions can be forced into higher concentrations than saturation by varying temperature or pressure and then allowing them to slowly return to the original temperature and pressure. This is called supersaturation. And that describes solid dissolved past saturation, more concentrated. Molarity is one type of concentration unit. One type of concentration unit. I was moving these words around, and I think I lost a few of them. Others include percent volume, percent mass, and parts per million. Okay, so I'm going to go back to that supersaturation idea. So if we go back up to our sweet tea up here, and we talk about Southern sweet tea, we're going to take our same sweet tea, but now I'm going to make that sweet tea. There we go. Oops, doesn't look right. There we go. Got that tea made up. But now this is hot. And while it's hot, that's when Southerners put sugar in. And guess what? You can put a whole lot more sugar in and it all dissolves up. You can keep putting it in, putting it in. Now eventually it won't dissolve. Like you can stir and stir and stir and you'll get that like layer of sugar that's kind of like stuck on the bottom. So eventually you will still hit the saturation point. But when it's really hot, it's your way of kind of tricking the solution. So in the South, we trick it. And in chemistry, we do this all the time. You trick the solution to take more in than it wants to. And you slowly let it cool to room temperature or room pressure. And it's great because it works perfectly. This is also the way that chemists make crystals. You would learn about that in organic chemistry. But like you can purify something with this and you can also dissolve things in and let them set and they'll turn into beautiful crystals. I love that part. Okay, so that's that whole page. We're finished talking about the idea behind it. Now we get into the math. I gotta tell you guys, this video, I found it recently. It's a new video and it is fantastic. It's 1 minute before you do anything else. Click on this link. It takes 1 minute. You see that? It's super awesome. All right, so watch that video and then come back to this because it just explains everything really, really, really well. All right, so molarity, what it is it's your moles of solute. So moles of solute in 1 liter of solution. So solute, remember that's a small thing. The solution is what, when you put the solute and the solvent together, you mix it up and you end up with the solution. Key thing that this is not the solvent. So just make sure you know that is not the solvent. That would matter for Jenkem 2. There's some units that have solvent on the bottom. That's Jenkem 2. So molarity of salt in water. This can be expressed a few different ways. I am sorry because I know that you like to just have one answer. This is what it can say. It can be like 2.0 moles of sodium. Sodium chloride in 1 liter of water, like we were just saying. I'm sorry, it's not water. That's the solvent. In 1 liter of solution. That would be the saltwater solution. And yes, that's a normal abbreviation for the word solution. We would also say, people are like, oh, that's too many letters. they would say 2.0 molar in ACl. I'm going to use that word because I jumped to it and I didn't mean to. You can also say 2.0 molar in ACl. And then you can also use brackets, and that's your NaCl concentration. So yeah, there's like different ways to say it. So in Gen Chem, we're going to be using the molarity, that big M, or the moles per liter. But if you hear any of us saying the word molar, or you see brackets or anything like that, don't be freaked out. It means something, and it does mean molarity. And here's my little picture, because I always got to have little pictures. So we got a little mole. We're not really talking about moles, right? Y'all know this, but it's just kind of fun to have a little picture. My mole is standing on a capital M, and the poor little thing, he's stuck in a container. And in the container, we have water. Oh no. The only thing that's keeping him alive is that great big M. So molarity, and this is at 1 liter. It's how many moles are in 1 liter of water. Of course, we'd have to mix them up and he'd be all dissolved, which is disgusting. So we're not talking about that, but that gives you a little picture of molarity. So the denominator unit for molarity, just to repeat, is liters of solution. Now, to give you some perspective of something in the lab, this is a very short video. I don't know, like a minute and a half, I think.
Today we'll be using a volumetric.
Okay, minute 45.
Today we'll be using a volumetric.
So this has a volumetric flask. It's a really short video. This is how you would see molarity in the lab. And the reason we talk about molarity is because in chemistry, wow, I just lost my thing. There we go. In chemistry, we do most of our chemistry, our solutions, because it's way easier to mix up a mixture and add it than trying to make a reaction happen in the solid phase. So most chemistry is in mixtures, just so you know. And then also, if you want to play around with something, this right here, that's a PhET diagram. Y'all know I like them. So this is a really easy one. You can see how, like, watch the color of it. If I increase the solute, that's the solid. See how it gets more red? Or like if I decrease it, see how it's getting less? That's less concentrated. Or I can also change the volume. So if I give it more volume, it's going to be less concentrated. See? Or less volume is more concentrated. So you can play with that. All right. Problem time. So let's actually work the problems and get on with everything, right? All right, so pro tip, if you see an M for now, while you're getting used to these units, cross out the M and write it as moles per 1 liter. And have a little typo here, that's 1.0. So here's our first example. What's the molarity? So question mark molarity, that's what we're trying to find. That contains 2.5 moles of solute and that much solution. So we just put them in. My formatting's just a little off. That one is supposed to be, here, I'll make it look like this. I'll make sure the formatting's good on y'all's. And there you go. Put that in your calculator. Make sure, if you are not using the E key, make sure you use a parentheses. If you are using the E key, you don't have to. How many liters of solution are used to create a 5 molar solution? So what we're trying to find is question mark liters of solution. Now, see the M? I'm scribbling it out, and I'm writing 5 moles in 1 liter. That's what that number is. Pro tip, don't put the molarity thing first. It has 2 units. 2 units means like conversion factor. It means use it later on. Don't start with it. Right here, 5 moles, that has 1 unit. You want to start with the thing that has 1 unit. 1 unit, this has 2. 1, 2, you don't want to use that. So we're starting with 5 moles. And then I'm going to put my moles on the bottom, my liters on top, and then this says that it is 5 moles in 1 liter. So that's why my 5 goes there and my 1 goes there. I do the math and I get 1 liter. So good times. So we have our level 1 problem. So I recommend you pause the video, make sure you make yourself actually practice it and think it through, and then come back, because again, that's that active learning you want to have happening. So you really should pause it. Like, don't keep watching, like pause it. All right, so question mark molarity. We know that molarity is moles per liter. It's the number of moles in a liter. This time we have 4 moles in 2 liters. You can kind of see the answer is 2 molarity. What about on this one? How many moles? So we're trying to find moles. Sorry, question mark moles. It goes on the left-hand side. Again, I'm going to scribble out the M. So I'm getting 9.0 moles in 1 liter. Don't start with that unit when you're doing stuff. Start with the other thing, 3.0 liters. And again, I'm putting my liters on bottom. I'm going to moles. And in 1 liter, there's 9.0 moles, which is 27. No sig fig wise, I'm multiplying things and they should only have 2 units. Next one, how many grams are required to prepare this many liters of that solution? All right, so we're asking for grams this time instead of moles. This is why it's level 2. It has 1 extra step in it. So we have something that has molarity, so I'm going to rewrite as moles in 1 liter. And notice this has 1 unit. Notice this has 2 units. So don't start with things with 2 units. Start with the thing that has 1 unit. 1.5 liters. All right, so again, I'm not putting the numbers in yet. So I want to go from liters, and I do have a liters over here that goes to moles. And then if I look at my other conversion, I have a moles on bottom, and then they go into grams. Oh, look, that's what I want, so that's good. I'm going to plug my numbers in. So remember that this is 2.00 moles in 1 liter, and that we have 40.00 grams in 1 mole. That's from this number over here. You do that math out, and you are going to get 120. Now, why is it 120 and not 123? Because I have 2 sig figs in one of the numbers. So I need to round it in such a way to give me just 2 sig figs. How many milliliters? Oh, by the way, wait. If we were to write that in scientific notation, we would write it like this. Not 12, because like 12 is not the same thing as 120. Sometimes that gets people. All right, now, how many milliliters of solution will be made when enough water is added to the 4.0 grams of NaOH? So again, that molarity, I'm going to change it to 2.0 moles per liter. Notice I've got a number here. And the fact I made that red is probably a key that you need to pay attention to. We've only got 1 unit. That's what you start with. 4.0 grams. Oops, sorry. I want to say that what I'm looking for is milliliters. So 4.0 grams of NaOH. It usually is a really good idea to keep what you're talking about in here. And then I'm going to go from grams of NaOH. And if I look up, I do have a unit that goes from grams to something else. It goes to moles of NaOH. And then I have a unit over here that's moles of NaOH in 1 liter. Now, can I stop? No, because it's asking for milliliters. So I'm going to do 1 more, liters into milliliters. Then I just put my numbers in, 40.00 in 1 mole, and then 2.0 moles in 1 liter, and then you put the 1 by the thing that has a prefix, 1 times 10 to the minus 3rd. Put all those numbers in, and you're going to get this. Now notice again, watch your sig figs. We've got 1, 2 sig figs, 1, 2 sig figs. And I would leave this one for you to do at home normally. But I will go ahead and do it. This isn't like anything different per se. This just says question mark molarity. So it wants to know the molarity. So basically what I need to have is I need to end up with a moles on top, and I need to end up with a liters on bottom. I just need to have it in those correct units. So right now I have a grams and I have a volume. You can probably see right now that volume will turn into liters. Oh, let me do that in a different color. My liters again, sorry, I've got my liters. And then I'm going to grab blue and do blue top. So here I've got 10.0 grams. And then I'm going from grams into moles. So 56.11 and 1 mole. Now, if you want to do the top, the blue one, and solve it and get a number, and then if you want to do the green part and solve it and get a number and then divide, totally fine. I was just trying to give you a different perspective on things. You also can put all this in your calculator. If you do that, you need to make sure that you write this with a parentheses around it. Or you do the conversion in your head and you go ahead and say, oh, well, that's the same thing as 0.250 liters, which is a good thing to just be good at doing, is turning 250 milliliters and know that that's the same thing as 0.250 liters. Dr. Bean talks about that in our video. But when you end up, you're going to end up with this number in molarity. Okay, so this is our last bit on this one. We have a little bit of thought again, trying to keep you engaged again, and then we've got a few dilution problems, and then we're done. So go ahead and pause. Try to fill them in yourself first. Okay, so the need to use a concentrated solution to prepare a more dilute solution is very common in chemistry lab. Many reagents are sold in certain concentrations, and we need to dilute them to get to the concentration we need. You guys have seen this even in stores. You know, you can like buy laundry detergent that's like 4 times concentrated, 10 times concentrated, because it's easier to ship, because you don't have the volume and you can get it at, like, it's more discounted. A lot of times it's more discounted. Same thing with chemistry. You know, they'll send us concentrated things and you don't want to work with it as concentrated, so you just add your own water and you're good to go. We do that in the lab for the Gen Chem folks. Okay, so the dilution is the process of adding solvent, I should be crossing these out, solvent, dilute, solution, usually water in Gen Chem 1, 2, and that would be decrease the concentration of the solution, because whenever you add water, you're decreasing concentration, you're making it more dilute. And as a reminder, moles over volume, increasing solvent means you're increasing the denominator. Oh, sorry, you're decreasing the solvent. Nope, it should be volume. You're increasing the volume, which reduces the concentration of the solution. Again, yours, I'm going to double check, make sure all your words are correct. The number of moles of solute in the solution. What happens to those? So we've got something, we got a container of something, we got our solute in there, and then we got some liquid. So here's our liquid. So let's say I want to like fill the liquid all the way to the very top. I'm just adding liquid. I'm not adding anything to those dots. Those dots are still there. Same thing with like tea. Like if you want to dilute your tea, you're not taking any of the tea out. You're just adding more water and diluting it. So it will not change. And the more dilute the solution, think about it, the more dilute. So you're making Kool-Aid and you add tons and tons of water. What happens to the color and the taste? It's less. The less intense the color and the taste. I'll fix all the words for y'all. Hopefully all you have are the right words up there. The opposite of dilution is to concentrate. That one's in there. A solution. Solvent is removed. If you're trying to concentrate something, you remove the solvent to decrease the volume, and it decreases the denominator. So by the way, this is evaporation, like you're evaporating some of it. And on Newton, you're going to see 2 formulas. These are 2 formulas you're going to be using today. You got this one and this one. I prefer this one. I saw this one in OpenStax, but also I saw this one on Newton. C stands for concentration, and molarity is a type of concentration. So that's why there's sometimes a C, and then this is molarity. So the 1 refers to the concentration and volume of the concentrated solution. Concentrated. And the 2 refers to the concentration and volume of the dilute. Now, honestly, I switch these all the time. You're still going to get the same numbers. So just make sure you have the molarity and the volume of the concentrated, like on the same side. That's the key part. Notice this though, both volumes should have the same units. You shouldn't have to convert them to any particular volume unit. And if you skip to the 7.02 on this video, it looks like this. He shows how to do a dilution. You're gonna have to skip past the video thing there, but skip to that part if you want to see a dilution in the lab. It's like 3.5 minutes, I think is what it is. Little pro tip: how to tell if it is a dilution problem, because this is our other equation. So notice earlier we had all the molarity where we just figured out molarity. So this is one type of problem, and then this over here, this is the second type of problem. Okay, so what we're talking about, this is the second time. So how to tell dilution and not just solve for molarity. So dilutions will need at least 3 pieces of information, because notice with the equation you've got 1, 2, 3, 4 things, so you need to know 3 of them to solve for the last one. And notice 2 of them will have the same kind of unit. You'll either have like 2 liters or like 2 volume units and 2 molarity units. They're also going to have the words like either dilute or concentrate and something like making a new solution or added to, kind of things like that. In both types, the word of is used to tie numbers together. I'll really try to emphasize that in this part. And to indicate multiply, you'll see that we do multiply things that are of'd. In regular molarity, we'll usually only have 2 pieces. Oh, and that's not including molar mass, because you gotta have that. Sometimes molarity does give you more information than 2 pieces. I'm just reminding you, you only need to convert to moles and to liters for molarity. So example problem. This is what I do with these. So we have this volume. So I know it's volume because it's a milliliter. So volume, and I'm just going to say 1 because I'm starting the problem. See how we have this of word? It ties those guys together. That's our molarity, 35 of this kind of molarity. See the is diluted to word right there. New volume, again, it's dilution. And then here's volume 2. Do a quick check. Are my units the same? Yes? Okay, I'm good. What should the molar concentration be? So again, we just are plugging in the numbers. So here's our molarity, and then here's our volume there, and then this is the other volume on that side. You're going to divide both sides by 100. That's how we got to this next step. So we divided both sides by 100. And then when you put it in, your milliliters cancel, and you're left with molarity. That's your new dilution. Notice you started with something concentrated and it became less concentrated. That's the point. But sometimes you'll start with something dilute and they'll have you go concentrated. But I'm just saying the point is that it changed. Okay, how many milliliters of this molarity? So I'm trying to find one of my volumes. I'm going to call it volume 1. That's my molarity one. Is required to prepare. Okay, so see milliliters. So that's volume 2. And molarity 2. Again, I've got that of word in there. And then double check my units. So milliliters and milliliters. Okay, I'm good. I'm going to come out with the right unit. That'll be good. So at this point, pause and solve these problems, and then log back on, or pause and then restart it so you can watch me work these 3 problems. So we got 0.224 molar, or molarity, times volume equals 5.0 times 10 to the 2 milliliters times 0.055 molarity. Then I divide both sides by the 0.224. That's going to give me volume is equal to 5.0 times 10 to the 2 times 0.55. Sorry, 0.055 and 0.224 molarity. Notice that this was a molarity and that was a milliliter, so those cancel. And notice that will give me the correct unit, which is milliliters. You plug that in your calculator, you're going to get that number. The reason it's 2 sig figs is because I have 1, 2 right there. Or you could say I have 1, 2 right there. Either ways, 1, 2 sig figs. And hopefully you remember how I said how to write that with scientific notation if you needed to. Next one, what's the molarity of solution formed by adding, okay, volume 1 of A, see of, so those are tied together, molarity 1, 2, and then here's our volume 2. And then we're filling it to the mark with distilled water. If you watch that little video, you could see what that meant. So basically you put one solution in and there's a marking here and you add enough water and then you mix it all up. That's how you get your new dilution. So MV, so 2.50 molarity times 30.0 milliliters equals 0.1000 liters times molarity. Now, I just noticed something, and you might have noticed this too. I didn't do my little check. So let's double check my units here. Oh no, my units are off. So I either fix it in the problem or I fix it outside the problem. You may be able to do this in your head, and if you can, that's awesome. If you can't, it's the liters times in 1 times 10 to the minus third liters in 1 milliliter. That's going to give you 100 milliliters. Actually, 100.0 milliliters. So I need to change this number and make it 100.0 milliliters. Now I should be good. Divide both sides by the 100.0. 2.5 molarity times my 30.0 milliliters divided by 100.0 milliliters. Those canceled. When you put that in your calculator, you're going to get this number over here. I dropped a 0, and that's why at first it looked like I didn't have the right sig figs. And last one. So if we have 50 milliliters of a 6.50, so again, volume 1, molarity 1 of is that, sorry, molarity 2, molarity 1, that of is that tying word together, is diluted to give, so this is our second molarity. What is the final volume? In liters. So quick check. Are these the same? They're not the same. So at the end, I need to remember to convert. I'm going to come out in milliliters. So I'm going to remember to convert my milliliters to liters. Or at the beginning, I can go ahead and convert my milliliters to liters. Can you do it in your head yet? You do it the same way as up here. You should get 0.050, 1, 2, yep, liters. That's my volume, oops, times my 6.50 molarity equals my volume 2 times my 1.30 molarity. Divide both sides by 1.30, 1.30, again molarity, molarity. Those numbers cancel, and when you plug it into the calculator, you're going to get this number over here. Notice that it's to 3 sig figs. You can pick out any of these. All of these all had 3 sig figs. All right, so in review, we talked about a solute. So that is, again, you can pause if you want to answer these really quick on your own. A solute is a substance that dissolves in a solvent, which describes a saturated solution. One that can hold as much solute as it can at a given temperature. True and false. Solute is added to a solvent to make a solution. That is true. Solvent is the least amount of substance in a mixture. That's false. It's the solute that's the least amount. That's the smaller word. Without changing the temperature or pressure, you can make a saturated solution more concentrated. No, that's false. You need to make a saturated solution is as concentrated as you can get at that temperature and pressure. Supersaturated would be when you're changing the temperature or the pressure. Okay, molarity is one of many units of concentration. That's true. There's others. To determine the molarity of a solution, you divide mass by volume. That should be moles. And this is going to have to be in liters, so that'd be false. It doesn't matter if you use the solvent's volume versus the solution's volume in determining. That is false. You have to use the solution volume. Volumetric glass, right now, if you watch those videos, you would have seen this one, has been designed to change concentration easily. That's true. Again, if you want to see that one, go watch that video. That's most closest to this section. And when you're diluting a solution, you have to convert all the volume units to liter. That is not true. No, but they do have to be the same. So they both have to be either be liters or they both have to be milliliters or I don't know, centimeters cubed, whatever you're using, they just have to be the same. And dilution changes the mole amount of solvent in a solution. That is what increases, yes, This does increase, because this is just saying it changes the amount of water in a solution. So yeah, that's what you're doing. So that's true. We have our learning indicators. Hope this wasn't too long for you. I just want to make sure and spell out every